going to do is we are going to implement what's known as a state estimator. And as the term says, we're going to estimate the state of the glycosylation in between the times that we don't have our glycosylation measurements. And so what we're going to do is we're going to basically develop a model that can predict what our glycosylation patterns are based on the culture condition set points that we have and the measurements that we actually have. And then once we actually get these glycosylation assay measurements, you can actually feed that into the model, update the model, and proceed with the control. So this is a very detailed control lingo for what we're doing. In more basic terms, what we actually need to do in order to accomplish this online control strategy for glycosylation, first, we need to develop a bioreactor system with nutrient control and metabolite monitoring so that we can get that second loop so that we can have the base regulatory control and we can precisely control all the process variables that we know to affect glycosylation. Second, what we need to do is we need to create a model that utilizes the process variables to predict glycosylation patterns. And then third, we'll have to determine what our crucial process variables are and actually quantify the relationship between the process variables and the glycosylation pattern. So once we incorporate all of these three together, it will enable us for online model-based control of glycosylation. So how are we on time?
You're about 30 minutes in.
I'm at 30 minutes in. All right, so I'm going to just go very quickly through some nutrient control stuff. So just to give you some pictures, this is my bioreactor system where I was able to develop a system that controlled our nutrients. And so this is your typical bioreactor, which has control over your agitation. We have a feed pumping system, so we can add in nutrients. We have a gassing system, a pH and PO2 module, and a temperature. And then this system here enables us to measure our glucose and our glutamine. Now, we have an autosampler that we can measure the glucose and the glutamine at any time interval that we want. And we have linked these two together through a software known as OPC, not that important. But basically, what this allows us to do is that the values that we're getting from our analyzer are able to talk to our bioreactor. And so with this, we're able to implement a feedback control strategy. So we wanted to maintain glucose within 10% of our set point. And we achieved that by implementing what's known as a PID controller. It's a very complicated, well, it's not that complicated. It's basically just a way that we can measure what our glucose is. We do some calculations and we figure out what flow rate we want our feed pumping system to deliver a glucose-rich solution. And so you can see that by implementing this PID controller, we also implemented a data filter, which basically just smooths out noise from our bioanalyzer, and we were able to maintain our glucose within 8% of our set point. So with that, we were able to maintain our nutrient control. And then I just wanted to end with what I thought was the coolest part about being an engineer. So I've actually got to travel quite a bit from working at Genzyme, from conferences, from being a PhD candidate. And so engineering is a lot of hard work, but there is some fun in it, and it's very, I really enjoy it. So there's lots. All right, so that's pretty much my spiel.
Yeah. Any questions? I'm sure there are a few.
So, in general, your presentation was, your goal was to basically find a more efficient way of glycosylation.
Yep.
By using a system that automatically corrects whether it's too much or too much.
Right.
And that's going to be very helpful in the production of medicine, right?
Right, because so glycosylation, it doesn't just affect monoclonal antibodies. That's just our model system that we're working on. Glycosylation affects almost every single protein that's produced. And that glycosylation pattern actually affects how that protein works in your body. And so we want to be able to reproducibly have a consistent glycosylation pattern so that way we can predict what the activity of that protein is going to be.
Because there's a lot of...